Welcome to the Copperspice YouTube channel, and thanks for joining us. In this video, we want to share our experience of renovating several projects using modern C++. What do you do when your codebase is old enough to vote? This presentation will be a little different, since it is a discussion about what we have learned by migrating several projects to modern C++. We will explore what comprises a codebase, the challenges related to refactoring or migrating code to a modern version of C++, and whether refactoring is really the right approach. As part of our analysis, we will address the technical aspects of what made C++11 modern and why your code needs to keep pace with the language.
The C++ language has evolved over the last 10 years, and the evolution appears to be accelerating. So how does this affect the projects you are working on, both personally and professionally? One of the comments we frequently hear is developers saying, my project uses C++ 14 or C++ 17, so that means my code is modern. Actually, this only indicates your compiler is modern. It says nothing about your code or how your project uses C++. Determining if your code is actually modern requires studying your source to see if it leverages the current idioms, semantics, and functionality of C++. When we use the term old code, we're not just referring to how long ago the code was written or when the project was started. The idea of old code in a project is more about how the abstraction is implemented. Older code can almost always be reworked and improved by using the constructs of modern C++. Doing so will usually make the code more efficient, improve readability, or allow the compiler to optimize more efficiently. One of the fundamental questions we thought about is how should the code be revamped, and is this an effective roadmap? So how do you figure out what to change and where to begin? These are the exact questions which should be addressed, and they should be tackled before you start ripping your code apart. Do you start migrating every class to an elaborate template? Or maybe move a majority of your code to a lambda, since those are cool. What if you start adding move semantics to older classes in your project? Will this be enough? We have personally battled these questions and dilemmas for the last 6 years, and several patterns have emerged. There is no definitive answer or one-size-fits-all solution. Our emphasis in this talk is about explaining the process we used to make our decisions and what we might do differently if we had the opportunity. One important consideration in choosing a path forward with legacy code is understanding the differences between the modern versions of C++. Are you aware of the subtle changes in const.expr? Do you know which expressions were marked as undefined behavior in early versions of C++? And when the standard changed, so now some things in C++ 17 are defined or unspecified behavior. In order to make well-informed choices, you will need to know multiple versions of C++ and the migration path of the language.
This is a list of some alternate titles we considered, and they are meant to be funny. On the other hand, if you really think about this subject, it involves more than just should we move to C++ 17 or maybe wait for C++ 20. This talk is about deciding when is the right time to update your toolchain and what is your long-term strategy to handle newer versions of C++. We have recently heard there are some prominent Silicon Valley and Seattle-based companies who are downsizing C++ development or moving away from C++ in favor of other languages like Java, Go, or Rust. There is nothing inherently wrong with switching languages, but the question is, why are they thinking about this? Our educated guess is the move may be a reaction to how old or obsolete the code is, and the fear of what it might take to migrate to a modern version of C++. These companies view migrating from their current code base as a major rewrite, and maybe it would be easier to move to a different computer language. To be fair, the choice to leave C++ might be the right way to go for some of these projects. Our suspicion is that these decisions may have been driven by the cost of talented C++ developers, rather than the technical merit of these other computer languages. Everyone has a set of features they want to see added to C++, so companies have a bad habit of waiting for the perfect time before they migrate forward. We wanted runtime reflection, and this is missing in C++. It took us a few months and a lot of work to implement reflection in Codebase, but it was absolutely possible. We used templates, decal type, and a compile time counter using constexpr. When metaclasses are finally added to the core language, it will not take much time to refactor our code. It can be counterproductive to wait until C++ has the one feature you believe will make migrating your code worth it.
Before you can think about migrating a legacy codebase, you need to think about all the pieces which comprise that codebase. When looking at a software codebase, people often overlook third-party libraries. If you are analyzing what it would take to modernize your code, it is important to review the status of every library and verify migration problems can be handled. As an example, what if one of the libraries your project links with is using C++ 14 and has no defined migration path for C++ 17? Are there restrictions in any library which would impact your ability to use a modern version of C++? As part of the codebase, you should also consider any file or document which defines the API or is related to the project, even if this file is not actually part of the source code. There should be a document which contains the coding practices for your project. As you migrate your source code to modern C++, this document should be updated to reflect whatever standards or restrictions must be adhered to by your team. If you do not have this type of document, you should seriously consider developing one. The migration process is a good opportunity to converge on a standard source code format, preferably using a tool like Clang Format or A-Style, so all your source code has a consistent look and feel. Internal documentation is another area which we consider as part of the codebase. Often updates to this are deferred until all of the code changes have been completed. This is actually not a good idea. Internal documentation should be done first or concurrently with the migration process. So what questions should you ask to determine if your codebase is too old and needs to be reworked? The first clue is, of course, calendar age. If the codebase was started before 2011, the odds are very good it contains obsolete ways of writing C++ code. As an example, in one project we migrated about 900 lines of C++ 98 macro source code into 10 lines of C++ 11, which used one variadic template. Even if you have partially updated your codebase with a modern version of C++, did you update the semantics and design of your code to take advantage of newer language features? If you are still using legacy tool chains on some of your supported platforms, this will be one of the first issues to address. Working around bugs in older compilers and maintaining backward compatibility in source code is awkward and may prevent you from really taking advantage of newer features. We strongly suggest you commit to using modern C++ consistently. Actively remove support for legacy systems and preprocessor defines used to deal with non-compliant, obsolete build environments. Removing backward compatibility code will improve readability, which ultimately makes the code easier to maintain and prove it is correct.
If your project relies on Boost, Copperspice, or another third-party library, It is vital to check with the vendor to ensure it will still work with your migration path. Some of the questions you should consider are whether the library is actively maintained with a vision of modern C++ and a modern design. Is the library really C++, or simply C compiled with the C++ toolchain? Are there parts of the library which will restrict how you can design your code? For example, what happens if the library uses function pointers in their API, which would make passing a lambda expression awkward? What if the library uses a code generator in ways which would prohibit using certain constructs in your source code? This was acceptable 10 years ago, but with modern C++, this may limit your usage of templates or multiple inheritance. You need to seriously consider whether the library will work properly if your code takes advantage of the native multi-threading functionality added in C++ 11. The other issue which can cause problems is incomplete or inaccurate documentation from a third-party vendor. The API documentation should be generated directly from the source code, so it is in sync with the implementation. A common problem we encountered was documentation which omitted key classes and documented virtual methods of a base class as belonging to a child class. This is misleading and very confusing.
If you are using a C++ 11 compiler, this is a good first step. We suggest moving to at least C++ 14, since it is not that big of a jump and was basically a bug fix with a few improved features. From here, a very valuable question to ask is, how much does your project actually use the features we have listed here? If you compile with C++ 14 and yet you never use or think in terms of move semantics, your project is missing out. We know a few people who have said that adding move semantics or extending value categories made the language too complicated. Our response is that they are looking at this a bit sideways. The question should be, why were move semantics added? The idea of moving is about transferring ownership of data from one object to another. Part of move semantics is defining which data types are movable, copyable, or both. The compiler now has the ability to optimize based on these semantics. If you are moving from C++ 11 to C++ 14, audit your code to see where you can use generalized lambda capture to remove workarounds for move capture. If you have const_expr methods, you may need to add const qualifiers. If you are not using const_expr, this would be a good opportunity to do so. If you are on a current compiler and have the full suite of C++ 17 available, check out the new standard library classes like any, optional, and variant, and study why they were added to the language. The string view class can be a major performance boost to code which passes around a lot of read-only strings. Fold expressions and structured bindings can simplify variadic template programming, and the const_expr if statement can completely change the way you implement templated functions. There is a cost to using an old version of C++, and it may restrict the pool of developers who will be willing to work on your project. Once most developers move to a modern toolchain, working on a legacy C++ project feels like you are programming with one hand tied behind your back. A common mistake we have seen is when management decides certain constructs of modern C++ are too scary. Their solution was to restrict and not allow good C++ developers to use anything which might be misused or misunderstood. So instead of using best practices, they had developers haggling over how to do something without using a variadic template, null pointer _t, or key parts of the standard library. This simply is not a viable strategy for long-term development, nor keeping good programmers happy at their job.
The hardest part of this whole process is evaluating your code base and determining if it is worth migrating. The options are basically migrate to a new tool chain, toss the code and start over, move to another computer language, or let the project die. If your project does not conform to modern C++ best practices, the first option is to decide if you want to stay in C++. For us, this was an easy choice. We migrated to modern C++. A step many companies forget is to ask whether the project has a long-term use. If the project is near end of life, it is probably not worth doing anything significant to update the codebase. If it seems like a sequence of straightforward refactorings would bring the code up to modern standards, then obviously you should do so right away. If invasive changes are required, part of the migration process will require evaluating the status of your team. It is very important to have a core group of developers who truly comprehend C++ 17 and management which is willing to give them the authority and responsibility to make the crucial and sometimes difficult design changes. If the code is brittle, it is very likely the scope of the migration will require more work. The tough question is whether your company is willing to invest the time and effort to update the codebase in its entirety.
Once you have decided your codebase is worth updating using C++, the next dilemma is when should you migrate the codebase? In our experience, waiting for the perfect time is pointless. There is simply never a good time, you just need to do it. Waiting to use variadic templates until fold expressions were added in C++ 17 would have been an option, but it means you would have missed out on the power of variadic templates for several years. The same holds true for any feature which will be enhanced in C++ 20. Start using what is available now, so you begin the process of changing the way you think about modern C++. If you are spending time developing workarounds to avoid variadic templates, you are paying an unnecessary price. Some of the newer keywords like override can actually improve the debugging process. Marking overrides of virtual methods will help the compiler diagnose a signature mismatch between a base class and a child class. This moves a difficult-to-find runtime error to a compile time error. The fundamental way to advocate for modern C++ is to look at how much time your team is spending finding bugs in old code which would not exist in modern C++. This is a major indication that the codebase needs to be updated. Although there are many developers on the CopperSpice team, the initial migration process on several of our projects was accomplished by using a small core group. A small, knowledgeable team can make the insanely hard decisions, which have project-wide consequences, without worrying about inhibiting the rest of the team. The migration team needs to have full authority to make these changes, including ones which can break backward compatibility. We like to think of these developers as an outside team who are essentially forking your project. Their goal is to redesign every section which is outdated, error-prone, and not optimized for modern C++. So what do you do with the rest of the developers who are not part of the migration team? They can work on maintaining the existing code, but this may not be the most effective use of their time. Why not have them spend time really learning C++ 17? Or maybe they can work on improving or creating a comprehensive test suite. Another idea is to have the remaining team work on refactoring the codebase to reduce dependencies and modernize isolated areas of the codebase, which will leverage the work the migration team is doing.
So after the migration team has settled on a version of modern C++ and updates to the toolchain have been completed, what do you do next? Our advice is to evaluate the compiler warnings and resolve all of them which are feasible. Any compiler warning which is related to an obsolete code construct will provide the migration team with a map of where to start making the big changes. As the next step, you should review the fundamental classes in your codebase and start redesigning the internals and revise the API to use modern C++. Add move semantics if appropriate. Mark methods as defaulted or deleted. When a class should receive arguments passed with stdmove, alter the API to take parameters by value. Expect all of these changes to break your codebase. That was actually the point of migrating the code. The migration team will need to resolve the collateral damage and let this point out other parts of the codebase which are using archaic ideas. Look for things like a container of raw pointers, copy on write, volatile keyword where an atomic was needed, usage of unions, and anything which has been superseded by newer constructs.
Another facet of migrating an older codebase is to improve the coding style. Select a style and enforce it. Using a tool like Clang Format or A-Style to convert the entire codebase will automate the process and can be used to make sure the project has one look and feel. A build system consists of more than just the compiler. Verify your project is using a recent version of whichever tool you use to create the makefiles. Document everything and decide if you are trying to support old platforms or outdated versions of an operating system. Source control software is mandatory, so make sure you are using a well-supported system. The Copperspice project uses Git since it is widely used in the open source community. Since you are migrating the code to modern C++, review your source control procedures so they meet current-day standards.
The Copperspice team has worked through the process of migrating multiple codebases. The key insight we discovered was that incremental changes or refactoring are simply not sufficient to migrate an old codebase. In order to really bring the code up to modern C++, we had to alter the way we thought and change the structure of the code. We freely admit this broke backward compatibility on every project. It feels good to announce that the Copperspice libraries are almost at a place where we can do a long-term stable release. One major obstacle we faced with migrating Copperspice was adding support for MSVC. Until very recently, Visual Studio did not provide full support of modern C++. Our hats off to Microsoft for their continued work on standard compliance. Copperspice now successfully builds using MSVC, and we are working with their compiler team to ensure Copperspice will continue to build with newer versions of their compiler.
For more information about Copperspice and the other projects we maintain, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us an email.
Please make sure you subscribe to our YouTube channel and come back in a few weeks for our next video.